During spinning, the fibres may be twisted in either a clockwise or an anti-clockwise direction. The staple yarn that we saw being produced was a singles yarn, that is, one length of yarn made from fibres twisted in a clockwise direction. Technically, this is called Z-twist, since the angle of the twisted fibres in the yarn aligns with the centre part of the letter Z. If the fibres are twisted in an anti-clockwise direction, this is called S-twist. Most single yarns are produced with Z-twist. It is common practice to twist two such yarns together to produce a two-fold yarn. This gives a more uniform and stronger product than an equivalent singles yarn. Also, good stability of twist is achieved, and the yarn does not attempt to untwist. A singles yarn will always try to untwist, and this can cause distortions in the knitted fabric. For very thick yarns, 3 single ends of yarns can be twisted together to form a three-fold yarn.
Synthetic continuous filament yarns, although stronger than natural spun yarns, are distinctly less bulky. A series of texturing processes have been developed to produce bulky synthetic continuous filament yarns without the need to cut and spin. This is a false twist plant. Like most texturing processes, this method uses a combination of mechanical distortion and heat to permanently deform the shape of the synthetic fibres. Nylon and polyester are the fibres most commonly false twisted. In this process, the yarn is highly twisted, heated and cooled, and then untwisted. This yarn has increased bulk and stretch. If the yarn is heated and then passed through fine meshing gear wheels, a crinkle yarn results. Alternatively, air jets can be used to entangle filaments within a yarn, which is then heated to stabilise the new, more bulky structure.
From the samples of yarn we have seen so far, there is obviously a wide range of thicknesses or weights. Clearly, we need some way of measuring and expressing this property so that we can specify what we require. Traditionally, each spinning system had its own method, some of which are still used. These systems are based on counting how many hanks of yarn of a stated length can be obtained from a pound of yarn. Today, the standard method of describing a yarn thickness, that is, its count, is the text system. The precise method is stated in a British standard. If a kilometre of yarn weighs 1 gram, then it is a 1 tex yarn. If it weighs 2 grams, 2 tex, and so on. Thus, the larger the tex number, the thicker or heavier the yarn. On the right is a 24 tex yarn, and on the left a thicker 80 tex yarn.
Before concluding this section on yarns, we should say that we have only illustrated the basic types. There are many others. For example, the self-twist process produces a two-fold yarn direct from the spinning stage. The two yarns are folded in alternate twist directions with a small section of zero twist at the changeover. High bulk acrylics are made by spinning a mixture of two different acrylic fibres, one with high shrinkage potential in steam and the other very low shrinkage. When the spun yarn is steamed or boiled, the one set of fibres shrinks and causes the others to buckle outwards. Elastomers, which include natural and synthetic rubbers, are specialist yarns of very high extension. The upper sample is uncovered natural rubber, while the lower is natural rubber covered with cotton yarn. The centre sample is the synthetic elastane lycra covered with false twist nylon. Both natural rubber and synthetic elastanes can be produced in various thicknesses.
There is also a very large range of fancy yarns. These are usually produced in the folding process with yarns of different colour or texture being twisted with a more conventional yarn. One yarn usually being fed at a faster rate, producing a bulky or looped effect. The variety of fibres, yarns and knitting structures available mean that garments of great diversity and properties can be produced.
To summarise, we can say that the chemical polymer structure is common to all fibres, natural, regenerated and synthetic. This produces the significant fibre feature of great length to width ratio. Staple spun yarns are produced by twisting fibres together, the particular spinning method depending on the fibre length and yarn properties required. Textured yarns are produced by the application of mechanical deformation and heat to synthetic fibres.
Having absorbed all this information, you might like to pull your own sweater to pieces and try and decide from which type of yarn it is made.